create an animated game environment, 4 directional keyboard-controlled characters, randomly positioned obstacles, and environmental art assets. Let's make games using HTML, CSS, and plain vanilla JavaScript with no frameworks and no libraries as usual. If I draw all my interactive elements on a single canvas element, layering can be a challenge. We can use built-in array sort method to reorganize game objects based on their vertical Y coordinate and draw them in that order. With that simple trick in place, we can have a player character that walks around obstacles in a way that makes visual sense. Let's build a game from scratch and learn about front-end web development and object-oriented programming. We will work with 3 files. In index.html, I create a generic, simple web page and I give it some title. I link CSS style sheet. I create HTML5 canvas element with an ID of canvas1 and I link script.js file. I create a div with an ID of a wrapper and I put canvas inside. I create an image tag with source overlay, alt overlay, and ID overlay. You can download all art assets in the video description, in the project files section. I'm also giving you all separate pieces in high resolution so you can compose your own unique background images if you want. Optimization tip number 1. Use plain CSS for large background images. I can draw and animate everything on canvas and I usually do that. Today I want to show you how you can combine CSS and canvas draw image method to maximize performance. This will negate the need to draw these large images on canvas over and over for every tick of animation, and it will improve performance of our games. CSS transforms use a GPU. They are faster and they have simpler markup because CSS has a lot of built-in keywords, which makes animating transitions much easier. Maybe for your game you need everything to be drawn on canvas, but today I will combine it with some CSS to take full advantage of the tools and techniques front-end web development environment offers. In style CSS, I give canvas a background image. You can download it in the video description, or you can put together your own background from the individual pieces I'm providing as well. As you can see, we created 2 layers. Background art, our character will be drawn on top of, and some overlay images, leaves and grass that will be in front of our forest scene. Player character will be able to hide behind them. Unless we set canvas width and height, it will always default to 300 x 150 pixels. We will make it the right size with JavaScript in a minute to reveal the full background artwork. I could have also put this background image on the wrapper element. I give the main wrapper element some border. My browser is zoomed out so I can fit everything on screen. The images I'm giving you today are optimized for 1280 x 720 pixel resolution, so the game we are building is pretty large. You can adjust the sizes if you want. If you are a beginner, it might be a good idea to follow my code exactly, use the same sizing and the same images, and only make changes once we got the entire project working. I want to center the container, so I give it position absolute. You can see that the wrapper doesn't start from the top left corner. There are some default margins and paddings. To make sure our page looks the same across all different browsers, I will do a global reset. I target all elements on the page and I set margin to 0, padding to 0, and box sizing to border box to make sure that elements padding and border are included in its total width and height. I want to center the wrapper div in the middle of the page vertically and horizontally, so I already gave it position absolute. Now I can give it top 50%, left 50%, and transform translate -50%, -50%. I also need to align the overlay, this image. I give it position absolute, top 50%, left 50%, and transform translate -50%, -50%. This will align it exactly on top of the wrapper. There are many more things we can do here. For example, let's bring another 2 images into the project. I create an image called leaves_left. I give it the same alt attribute and ID. You can download all these images in the video description. I create another image called leaves_right, like this. These could have been just a part of the main overlay image, but I want them to be animated and interactive. As we said, CSS transforms are processed by GPU, so let's take advantage of that to make our game world feel a bit more alive and interactive. Let CSS do some work for us, not everything needs to be drawn on canvas. It will all blend together really well and our game will look great. I target leaves left, I set top position to 50 pixels, left position to -100. Leaves right will be positioned -150 pixels behind the right edge. Up here on the main wrapper I set overflow to hidden to clip and hide everything that's outside the main game container. We can do so many things with it now. For example, we can have the leaves move out of the way when we hover over canvas. We are just a silent observer hiding in the bushes. Let's push the leaves out of the way a little bit so that we can see better. So when I hover over canvas, I want to apply some CSS to leaves left. I will change their left position and I will rotate them by +15 degrees. This CSS declaration will not work. It would work if leaves left was a child of canvas element, but it's not. If we look here, we can see that they are siblings. They are on the same level in element 3 and they both share wrapper as a parent. To apply something to leaves left when canvas is hovered over, we need to use something called the general sibling selector. General sibling selector selects all elements that are next siblings of a specified element. If I look at our element structure, we have canvas element and overlay image is directly on top of it. It's actually blocking the hover event on canvas from triggering. I want overlay image to be on top, but I want it to be invisible for all mouse interactions so that I can interact with canvas that is underneath it. I can do it by setting pointer events property on overlay to none. Like this. Right now canvas is only this small area, but soon we will resize it to fill the entire container. To test the hover event, for now I have to move my mouse over this small canvas area here. It works. On hover, I set left position to -150 pixels. I will give leaves some transition time so that it actually animates. Let's try 0.3 seconds. Nice. I do the same thing for leaves right. I also give it some transition, maybe just 0.2 seconds, so they are not completely synchronized. We can do so many things. For example, apply keyframes animation to make it look like the leaves are moving from the wind. I'll call it wobble. At 0%, it will start at top 50 pixels. We will have 50% breakpoint at 55 pixels and at 100% it will go back to 50. We can apply it by giving leaves left animation property. We called it wobble. Time in will be ease in out. Time of animation loop will be 1.5 seconds, like this. Like this it will run just once, but I want an infinite loop. I don't see any movement. Let's set this to 65 pixels. Right, I need to make sure I have the right syntax for keyframes. This semicolon has to be here. And we have leaves moving in the wind. Let's try 56 pixels. I copy this line and apply it also to leaves right. I want to desynchronize them, so loop on this one will be 1.6 seconds. Same as we did with overlay, I need to set pointer events to none on both leaves to make sure they don't block mouse events on canvas that's underneath it. And this is how you can draw and enhance part of your game world scene with CSS. It's a good practice when it comes to performance, so if your project allows it, feel free to use it more often. We will also draw some images with JavaScript, mainly our animated keyboard-controlled owlbear character. When we work with images in JavaScript, we always need to make sure that the image is fully loaded and available before the code that depends on that image is executed. Otherwise, we will get an error. There are many ways to do this. We can use promises, or a very simple way is to wrap all JavaScript code inside load event listener. Load event is fired when the whole page has loaded, including all dependent resources such as style sheets and images. This way I can just put my sprite sheet as a regular IMG element in index.html and JavaScript will wait for that image to load. Inside the anonymous callback function here, I set up my canvas. We need a reference to the canvas element, so a constant variable I call canvas, and I want to point JavaScript towards this canvas element we created on line 12 in index.html. We gave it an ID of canvas1. You don't really need to use getElementById here because all browsers automatically create JavaScript variables for all elements with an ID. This automatic variable name is always the same as ID. It's good for debugging, but because browsers put all these variables into the global namespace, these variables are easy to accidentally override, so it's better if we use getElementById like this. CTX context is canvas.getContext2D to generate an instance of built-in Canvas 2D API that holds Canvas state and all 2D drawing methods. The parent wrapper element was set to 1280 times 720 pixels. Let's make sure that canvas element is the same size. This will reveal the full background artwork. What do you think about it? As I said, I will also share individual pieces with you in high resolution. You can mix and match them and create your own unique game environments if you want. All art assets I'm sharing in this video are copyright free. They were designed and drawn by me or by artists I hired. You can modify them and use them however you want. I will comment out CSS animations on lines 39 and 31. I think it will be less distracting. We have some JavaScript coding to do now to bring our animated character to life. Let's follow the principles of object-oriented programming today and split our code into individual classes. Each class will have different responsibilities, and we will make them communicate and work together to create the final product. Custom class I call, for example, input handler will handle keyboard inputs. When a key is pressed on a keyboard, this class will process that and it will transform and store that value so that it can be used by other classes. Class owlbear will be our main animated character. Player will be able to control it using keyboard. Class object will be used as a blueprint to create randomly generated trees, bushes and grass. Once we place them into the game world, we will learn how to organize them in a way that they are drawn in front and behind the player, depending on where the player is currently standing. This is very important because without it, in a game like this, drawing player on top of everything wouldn't make visual sense. We need some logic so that the player can walk around these 2D obstacles, and I will show you an easy way to do it. Finally, we will need a class I call game. This is where all the logic from all the classes comes together. This will be the main brain of our code base. Class constructor will create an instance of a class for us, based on a blueprint we define inside. So let's define a blueprint for our main game class. I want these classes to be self-contained and modular. So we will pass it width and height of the game area as arguments, like this, and we convert them into class properties. We take width and height passed as argument to the class constructor, and we convert them into width and height properties on this instance of game class. To create an instance of game class, I create a constant variable I call, for example, game, and I use the new keyword. The new keyword in JavaScript is used to create an instance of an object that has a constructor function. New keyword will look for a class with that name, and it will trigger its constructor. Constructor will create one new blank JavaScript object, and it will automatically set its prototype behind the scenes. It will bind its this keyword to point to this newly created object, and it will assign the object all the properties and values as we define them in the blueprint here. So far, our game object will only have width and height properties, and in this case I can see that these properties are expected as values that are being passed from the outside. We do this to keep our classes self-contained and modular. I pass it canvas width from line 4 as width, and canvas height from line 5 as height, because I want the game to be the same size as canvas. I want the game area to use up the entire canvas element. So this is how you create a class in JavaScript and how you create an instance of that class, how you use that class to create one object based on the class blueprint. Let's console log game variable from line 26 to check if everything went well. In console, I can see that game variable stores a reference pointing towards a game object with height and width properties set to the right values. Perfect. If you get any errors when writing your object-oriented code base, you can always console log your objects like this and check if all these properties have values. If you see undefined here, you know there is a problem in your code, and you can track that value back through your code base to find the issue. Input handler class is here to keep track of keyboard keys as they are being pressed and released by the user, and it will convert them to values that can be used by other objects in our code base, and it will store them. I give it a constructor as well, and this is how we will make our objects communicate with each other. Input handler will expect a reference pointing to the main game object as an argument, this entire object. Inside, we convert that reference into a class property like this. So, game that was passed as an argument is converted to game property on this instance of input handler class. Objects in JavaScript are reference data types, so I'm not creating a copy of game object here, I'm just creating a variable that points to a space in memory where the main game object is stored. This is great because when values of game object update, those changes are immediately visible from this .game reference here. On the main game class, I create a property called this.lastKey. Input handler class will be updating this value on game class as keys are being pressed and released. Initially, I set it to undefined. Today we will learn about keyboard controls, and we will only hold the last key that was pressed or released in memory. It's all we need to control 4 directional 2D character. If I wanted to keep track of multiple key presses, I would create an array here instead, and I would add and remove keys from there. I've done it before, and I might do it later in this series, depending on how complex and precise keyboard controls we will need. I also want to automatically create an instance of input handler when I create the game object, so let's put a console log here that says input handler created. Inside game class constructor, I create a property called this.input, and I set it equal to new input handler like this. On line 8, I can see that input handler class constructor expects a reference to the main game object. Here I am creating input handler instance inside that game class, so I pass it this keyword. This keyword used inside game class points to the entire game class itself. It represents the object inside which it was defined. Nice, so because I put this code inside game class constructor, when I create an instance of game class on line 31, it will also automatically create an instance of input handler class for me, and it will save it as a this.input property on the main game class itself. I can confirm that input handler was created because I see this console log here. Perfect. This is a simple way how you can connect your classes and make them work together to create a full game. It's also very modular, so you can later add more features and more classes to your game if you want. As we see with this console log, all the code inside class constructor is automatically executed when an instance of that class is created. That code doesn't always have to be just defining class properties, we can put any code in here. In this case, I want to apply event listeners automatically when an instance of input handler class is created. So I will just put them in here. We will listen for the key down event. In the callback function, I will run a console log. Callback function on event listener in JavaScript has access to auto-generated event object that contains all details about the event that just fired. I can assign it a variable name here. Convention is usually a letter E like this. I've done this before, so I know that this auto-generated event object has a property called key that gives us the name of the key that was pressed. I will console log e.key. I need to click on canvas to make sure it's selected, and when I press anything on keyboard, the names of the keys are being printed in the console. Today we will focus on directional arrow keys, so arrow left, arrow right, arrow down and arrow up. I want to save these key values inside last key property from line 28 on the main game object. We have a reference to the main game object here on line 9, but when I console log this.game from inside the event listener, we notice that the reference returns undefined. It's because this callback function forgets that it was initially defined here inside constructor method on input handler class. I want the function to remember. I want to bind its scope so that a reference to this keyword, in this case representing this input handler object, as well as access to this .game property, will be available from inside this callback function on keydown event listener, whenever that event listener runs later on. I want to make sure this function never forgets that it was initially defined sitting inside an object. I can use JavaScript bind method to do that, or I can simply use ES6arrow function. ES6arrow functions don't bind their own dis, but they inherit the one from the parent scope. We call this lexical scoping. The scope of arrow function will always depend on where in our codebase it was originally defined, on its original lexical scope. In our case, it was defined here inside this constructor method, so it will always have access to this .game property and any other properties we might define inside this constructor later on. When I refactor this callback function to an arrow function, we are able to console log this .game, and we see that it points towards the main game object and all its properties are visible there, including last key. If I console log last key value from line 28, initially it is set to undefined. So we take the key property from event object and I assign it to it like this. Now, last key property on the main game class always keeps track of the last key that was pressed. I also need to know when the last key was released, so I create another event listener, this time for key up event. Now we are storing the name of the last key that was pressed or released. The problem is that it just registers the key's name. I need to know if that key was pressed or released, so I will concatenate capital letter P inside keydown event to specify that the key of that name was pressed. I will then add capital R in front of the name of the key inside key up event, so that we know that key was released. Now we are getting these values in console. You can see the value of this .game.last key property is changing. We press arrow right here and we release arrow right here. I can remove the console logs now that we know it's working. So on the main game object we defined last key property and we created an instance of input handler class. As input handler class gets initialized, we apply key down and key up event listeners. These will dynamically update that last key property so that our game object and all objects connected to it are always aware which key was pressed or released. We will use those values to control the player character, the owlbear. Let's define it here. First, we need to connect it to the main game object, so we make sure it expects a reference to the game object as an argument. And inside, we convert it into a class property, as usual. Let's start by giving it width and height of 100 pixels. Its initial position will be 200 pixels from the left edge and 200 pixels from the top. I give it a draw method to draw it on canvas. It will expect context as an argument to specify which canvas element we want to draw on. I take that context variable and I call built-in fill rectangle method on it. Fill rectangle expects x, y, width and height, so I pass it properties from owlbear constructor. We want to draw a black rectangle representing the owlbear at first. Same as we did with input handler class, I want to create an instance of owlbear object automatically when I create an instance of the main game class. So I instantiate it here inside class constructor and I assign it to a class property I call this.owlbear. Up on line 20 I can see that it expects game as an argument, so I pass it this keyword because we are inside this game class. Game class will have a special method I call render to update and draw all game objects on canvas. I take this.owlbear from line 42 and I call its associated draw method from line 27. That method expects context as an argument, which is this ctx from line 3. I need to pass it along. I will still call it context. It will be expected as an argument by the main render method and we pass it along to draw method on owlbear. I take a game, I call its render method from line 44 and I pass it ctx from line 3 as an argument. that will get assigned a variable name context and passed along where needed. Perfect, we are drawing our owl bear. It looks like a simple black square because that's what we defined here inside the draw method on owlbear class. Let's make it move. I give it a custom update method, and for every animation frame I want x to increase by 1, making it walk to the right. We have to actually call that method from inside render on game class here. I delete this console log. To actually see the movement, we need to be calling this update method over and over. Calling it from render just once on the first page load, like we are doing here, won't animate anything. We will need animation loop. I create a custom function I call, for example, animate. Inside, I put this render call. To make it loop, I call built-in request animation frame method. This method will update our web page before the next repaint by running a code in a function we pass it as an argument. If I pass it animate, the name of its parent function, it will create an endless animation loop. Animate gets called, it calls render to draw and update our owlbear, and request animation frame will trigger animate again, so the cycle will repeat itself. Request animation frame sits on the window object, representing the browser window, but it can also be called directly like this, without putting window dot in front of it. It's better to use request animation frame for animation than using set interval. Request animation frame adjusts frames per second to your screen refresh rate, and it also auto-generates a timestamp for us. We might need it later. To trigger the animation, I just call animate like this. Nice, player is moving to the right. It's leaving trails. We need to make sure we delete all canvas drawings between each animation loop. I do that by calling clear rectangle built-in method. I want to clear the entire canvas from coordinates 0, 0 to canvas width and canvas height. Now we have a moving black square representing the player character. Perfect. It's moving to the right because here inside update method on owlbear class, which is our player, we are increasing horizontal x position by 1 for each animation frame. I give it a property I call speed x. Initially I set it to 0. We will also need speed y, vertical speed for up and down movement. Remember that we are building a keyboard controlled character that can walk in 4 directions. I will increase this .x by the current value of speed x, like this, and vertical y coordinate of the owlbear will be increasing by the value of speed y. This is great because I can give it a positive value to move to the right and a negative value to move to the left. I can make it move faster by giving it a larger value per animation frame here. This number means pixels per animation frame. Positive value in speed y will make player move down. Negative value will make it move up. Positive value in both x and y will make it move down right. We could easily use this for 8-directional movement, as you can see. Up here on line 7 we have input handler class that captures keyboard input. It transforms the default key names to indicate whether the key was pressed or released by prepending P or R in front of the actual name of the key, and it saves the value of the last key that was pressed or released here on line 46 inside this .lastKey property on the main game class. Because I'm passing a reference to this entire game class when I create owlbear on line 48, owlbear object has access to last key value through this .gameReference here on line 21. I can say if this .game.lastKey is P arrow left, if arrow left was pressed, set speed x to -1 to make the character move to the left in the negative direction on horizontal x-axis. If I click canvas and I press left arrow key, we are moving. Perfect. When I release the key, the player doesn't stop. Up here I can see we are capturing the value for press and release. I can say else set speed x to 0. Now we can move left and we can stop. I could also create a set speed method that, whenever it's called, it will set speed x and speed y. These will be passed to it as arguments. We take those arguments and we update class properties from line 26 and 27. Now I can replace this line with this .setSpeed and I pass it -1 as speed x and 0 as speed y. In the else statement, I set both horizontal and vertical speed to 0. It's better to have a global max speed variable rather than hard-coding +1 and -1 here, in case that speed needs to be dynamic. Player can have some temporary speed boost, or maybe player is moving slower while crawling and prowling. To do that, we define max speed property. We set it to 3 pixels per animation frame and we replace it here. Let's expand this statement. I will also check else if this.game.lastKey is pressed arrow right, like this. In that case, we set speed x to plus max speed and speed y to 0. So now we can move left and right and we stop moving when the arrow key is released. Perfect. Another else if block. Be careful about the syntax and the brackets. It's very easy to miss one bracket and break the entire code base while doing this. When we press up arrow key, we call set speed. We set speed x to 0 and speed y to minus max speed, because we want to be moving up in the negative direction on vertical y-axis. We do one more else if block. If last key is press arrow down, like this, we set speed x to 0 and speed y to plus max speed. Awesome, we can move left, right, up and down. I want to make sure that the player can't leave canvas. I need to set some horizontal boundaries. If player's horizontal x position is less than 0, set it back to 0. That's the left boundary. Else if player's horizontal position is more than this.game.width, the width of the game area. This.game is coming from here, and from there we are navigating to this property on line 64. So the player's current position is more than the width of the game minus the width of the player, which we defined on line 22, meaning that the right edge of player rectangle is touching the right edge of canvas. Make sure that player can't move further to the right anymore, like this. I will increase player speed to 10 pixels per animation frame. And you can now move left and right to test the horizontal boundaries. Vertical boundaries will be slightly different because in our game world the ground ends here. I don't want player to walk over this area unless it's a flying creature, I guess. This owlbear is definitely too heavy to fly. I wonder if there are any rare flying owlbear species. We might look for them later in the series. We have this area on top where I don't want the player to be able to walk. I create a class property called this.topMargin. Initially I set it to 200 pixels. Let's put it here. Up here we will define vertical boundaries. I say if this.y is less than 0, y is equal to 0. This will create a boundary here, so the player cannot go up past the top edge of canvas. I actually want the boundary to be lower because all of this environment art. I say 0 plus this.game.topMargin, like this. I can delete 0 plus here, of course. Now the top boundary is here, 200 pixels from the top edge. We can walk around, but we can't walk up here anymore. Perfect. It will make more visual sense when the player is an actual animated character, not just a black square. We are getting there fast. Bottom boundary is simple. If player's vertical Y position is more than height of the game minus height of the player, meaning that the bottom of player rectangle is touching the bottom edge of canvas, don't allow it to go any further down, like this. Let's test it. Yes, we have all 4 boundaries. Perfect. Let's turn this simple black rectangle into animated 4-directional character sprite sheet. I start by adding sprite sheet image into index.html, like this. We do it this way because all our JavaScript is inside load event listener, so if I place my sprite sheet here, JavaScript will wait for these images to be fully loaded and available before it starts animating them. You can download all project art assets in the project resource section below. I gave it an ID of owlbear. Let's bring it outside the wrapper like this. You can see we have 8 animation rows in the sprite sheet, 4 directions, and each direction has idle and walk-in loop. We will look into that further in a minute. I will hide the image itself with CSS. We want to draw it with JavaScript on canvas. You can see that all the code is inside load event listener, so all this code inside will run only when owlbear and all other images have been fully loaded. Down here inside constructor on owlbear class, which is our player control character, we will add a reference pointing to that sprite sheet image as a class property. I call it this.image and I set it equal to a variable called owlbear. That variable was not declared by us, but all browsers automatically create references, auto-generated global variables to all elements with an ID. This element has an ID, so we know that our browser automatically generated a global variable for it. Normally we would use getElementById here on line 29, but we don't have to. The only problem is that this is a global variable, so that we are pulling global variables into our classes right now, and that variable is in constant danger of being accidentally overwritten. Let's just test if it works anyway. I take context referring to ctx variable from line 3, and I call built-in canvas drawImage method. DrawImage expects at least 3 arguments, so I pass it this auto-generated global variable that was created from element's ID as the image we want to draw, and I pass it this.x from line 24 and this.y from line 25 to tell JavaScript where on canvas we want to draw the image. Now we are drawing the entire sprite sheet at these x and y coordinates. We can move around using arrow keys because of the logic we wrote earlier. It's safer to use getElementById here, so let's do it. I use this.image here. Okay, that still works. Nice. To animate any sprite sheet, we need to know dimensions of a single animation frame within that sprite sheet. I will put these into separate variables. I call the first one sprite width and I set it to 200 pixels. Sprite height will also be 200 pixels. If you are using a different sprite sheet, you can calculate sprite width by taking the width of the entire sprite sheet and divide it by the number of columns. Sprite height is the height of the entire sprite sheet image divided by the number of rows. In this case, width and height properties will be the same as sprite width and sprite height, but keeping them separate might be a good practice because we can then use scaling or randomize the sizes here without affecting these values that always need to stay the same to correctly crop out individual frames from the sprite sheet. DrawImage has 3 versions. The first version expects 3 arguments, we just did that here on line 35. The second version takes 5 arguments, optional 4th and 5th arguments define the width and height of the image, and the image will be stretched or squeezed to fit these dimensions. Now I'm squeezing the entire massive sprite sheet into an area of 200 times 200 pixels. The third version of drawImage method expects 9 arguments to give us the most control over the image we want to draw, and that's the version we need to use to animate our sprite sheet. These 9 arguments are the image we want to draw, source x, source y, source width, and source height of the area we want to crop out from the source image, and the last 4 arguments we call destination x, destination y, destination width, and destination height. These will define where on canvas we want to draw that cropped out piece of image onto. Let's say I just want to crop out the top left corner frame, so I'll be cropping from coordinates 0, 0 to sprite width and sprite height. Values we set to be exactly the same size as a single frame in our sprite sheet, in this case 200 times 200 pixels. Nice, we are using drawImage method to crop out a single frame. I can multiply sprite width here by a number and sprite height here as well. Now I have a way to jump around the sprite sheet from frame to frame. 0, 0 is this one, 10, 0 is this one, 20, 0 is this frame. This number navigates horizontally. This other number will determine which row in the sprite sheet we are on. You can see we can jump to a different animation row every time I change this number. I will put these values into class properties. Frame X will handle horizontal sprite navigation, frame Y will be for vertical sprite navigation. Again, when frame X and frame Y are 0, 0, we are showing the top left frame. I can change these values to jump around the sprite sheet. Now that we understand how these arguments passed to drawImage method crop out individual frames, we can actually animate our sprite sheet and really bring this mighty owlbear to life. Let's start by just animating a single row. So for each animation frame, if frame X is less than max frame, in this case max frame will be the number of frames per row, so 30. If frame X is less than 30, keep increasing frame X by 1. Else, meaning it is equal or more than 30, reset frame X back to 0 so that it can cycle again. Good, we are animating this row because here we set frame Y to 3. If I set it to 0, we are animating this row. As I change this number, we are animating different rows. We want to swap these animation rows depending on two things: which direction is the player walking, and is the player walking or just standing. If we had a complex character with multiple attack moves and so on, I would suggest to do a state design pattern here, like I did in the Endless Runner class. But in this case, the movement and animation logic is simple enough to be handled here inside the update method. We can always expand it to a state design pattern later, if we decide to add more player moves. Let me show you. Here we are setting player speed based on which of 4 arrow keys were pressed, left, right, up or down. Let's copy this code block. Be very careful about brackets here, it's easy to miss one and break your code. If you remember, up here we are keeping track of keys that were pressed and released. Pressed keys start with capital P, released keys start with capital R. How do we do this? I think this should work. When we press left arrow key, we want to animate this row, so this.frameY is equal to 3, walking left animation row. Else if, when we release arrow left, like this, we set frame Y to 2. We want just standing idle to the left. Let's test it. I need to set speed to 0, when we release here. That's better. When we press arrow right, I want to animate walking right, so this row. This.frameY is 5. I copy this else if, careful about brackets. We change P to R here. When we release arrow right key, we set speed to 0, and we set frame Y to 4, idle right animation. Perfect. We have a character that can walk left and right, and the logic we just wrote correctly navigates around the sprite sheet. We are walking and we are standing. Player is animated and it is correctly reacting to keyboard inputs. Nice work. Let's also do it for vertical up and down motion. When we press up arrow key, we want the player to walk away from the camera. Frame Y 7. I copy this code block. When we release up arrow, we animate frame Y 6 and we set speed to 0. We can walk left, right and up. Here, when we press arrow down, we want to animate frame Y 1. I copy this code block. When we release arrow down, we animate frame Y 0 and we set speed to 0. We are walking and animating in 4 directions, and we are correctly swapping between standing and walking animation for each of these directions. Amazing work! To create an idea of depth, to make it feel like the player is walking away and towards the camera when walking up and down, I will make it move a bit slower on that axis. Look how much difference it makes. It feels like there is more depth, like the background is further from the camera than the foreground. We walk at a normal speed, left-right, but up and down we walk a bit slower. Let's change max speed to 5. This is a big heavy creature, it should move slower. I comment out the black rectangle, we don't need it right now. I really like this, we have a base for so many different games. All you need now is your creative ideas. We can do so many different things with this, and as you learn more about JavaScript, Canvas and game development, it will become easier and easier to actually turn those ideas into a working code base. Let me show you more. I hope you are getting some value today. Let me know in the comments if you learned something new. Because we are using only the last key that was pressed or released to control the player character, there is a common problem that when we walk in one direction, let's say I'm walking right, I press left arrow key, player turns left, and only then I release right arrow key. The last key is release right, which will make the player stop briefly before continuous holding of the left key makes it walk left again. You can try and you find that we will have this problem in any direction. Walk somewhere, and when you press a different directional key before releasing the previous one, it will make the player stop for a bit before it continues moving in that new direction. To fix this is easy. When we release arrow left, we want this code only to run if player's speed is less than 0. Only stop the player and make it animate idle to the left if the current player speed is less than 0, if the player is currently moving to the left. That way we can enter idle left only from walking left state. When we release right arrow key, we only want to stop movement speed and animate idle right if player is currently moving right, if its speed x is more than 0. I also have to remove this else statement here, and now we fix the issue for left and right motion. Let's do the same thing for up and down motion. Only run this code when we release up arrow and at the same time player's movement speed y is less than 0. And when we release arrow down, only run this code if at the same time speed y is more than 0, only when the player is walking down towards the camera. Now we are moving around and the glitch is gone. Well done! If I set max speed to 2, player moves slowly, but the sprite animation serves frames so fast that the player is kind of moonwalking. The feet animate in a way that doesn't match movement speed and it looks very bad. One way to solve this is to manually control how fast the sprite sheet animates. Right now we are just serving one new animation frame per loop, every time request animation frame is called. Let's create a functionality where we can manually set FPS, frames per second, for the animation speed of our sprite sheet. It can be done globally and we can set FPS for the entire game, or, as I will show you now, you can set FPS individually for the player object. Maybe we will have some enemies later that will have different sprite sheets and we might want those sprite sheets to be animated at different speed. By default, request animation frame will adjust itself to screen refresh rate, so our game will run faster for someone with high refresh rate screens, like those new gaming screens. We can control that if we want to. Request animation frame has a special feature where it generates a timestamp every time it calls animate function, and it passes that timestamp as an argument to that animate function it calls. Let's use it to count milliseconds between frames so that we can set our own FPS, frames per second. I create a variable I call last time. It will sit outside animation loop like this. Initially I set it to 0. It will hold the value of timestamp from the previous animation loop so that we can compare current and old timestamps and determine how many milliseconds passed in between. The value is called delta time. Delta time is the number of milliseconds that passed between the timestamp from this animation loop and the timestamp from the previous animation loop. So to calculate delta time, we know we need to compare those timestamps. Timestamp from the previous loop will be held in last time variable here. Initially we set it to 0 before we start generating timestamps. As I said, request animation frame passes auto-generated timestamp argument to the function it calls. If you are a beginner, imagine that it's being generated and passed here, like this, at the point when request animation frame triggers that function. So we assign that auto-generated timestamp a variable name here. I will just call it timestamp, spelled with a capital S. Let's comment this out and console log timestamp just so that I can see what format we are getting. You can see that it's milliseconds. The first value is literally the number of seconds since the loop started. 4, 5, 6, 7, 8. So this is the timestamp. I delete the console log. Delta time is the timestamp from this animation loop minus last time from line 113, which will always hold a value for timestamp from the previous animation loop. Once we calculated delta time, we set last time to timestamp so that this new timestamp from this loop can be used as old timestamp value in the next following animation loop. So now we have delta time. It tells us how many milliseconds it takes for our computer to serve one animation frame. My screen refreshes at around 60 frames per second, so my delta time is around 16.6 milliseconds. This is perfect. Are you getting the same delta time or are you getting a completely different value? Let me know in a comment. It will depend on the refresh rate of your screen and partially also on the power of your machine. Weaker machines will have higher delta time. You can see that here the first delta time values are none, not a number, because we first run animate here, and in the first loop this timestamp is undefined. There was no previous request animation frame call to auto-generate it for us. To fix this, I need to make sure I pass it that first timestamp here, just to avoid none, not a number value in the initial loop. Otherwise it might give us problems later, depending on how you want to use your delta time values. Initial timestamp will be 0. You can see the values are all over the place at first, but then they quickly settle at around 16.6 as our animation loop runs over and over. This is ideal. I delete the console log. I pass this delta time value to render method on game class. I make sure that value is expected here, and I can pass it along anywhere around our game now, wherever we need it. I pass it to update method on owlbear class because we want to use delta time to control FPS, frames per second of sprite animation there. So I'm passing delta time to update method, and I need to make sure it's expected here on line 44. We are inside owlbear class now, and we can use delta time value here for so many different things. To control FPS of sprite animation, I will create 3 helper variables, class properties. FPS will be 30. Let's try to animate 30 frames per second and see what that looks like. Frame interval will be 1000 milliseconds divided by 30. This will determine how many milliseconds should pass before we swap to the next frame in the sprite sheet. Frame timer will be the counter. It will be accumulating delta time over and over as our animation loop runs. When it reaches the value in frame interval, when enough milliseconds have accumulated, we trigger certain periodic action. In this case, we will serve the next animation frame. Same technique can also be used to add a new enemy to the game or some other event that you want to be happening in a specific interval. This is an important technique to understand. Let's write the logic and explain it when we see the code. It's just a few short lines. I only want to run this code that swaps between sprite frames when enough milliseconds passed. If frame timer is more than frame interval, only then animate the sprite sheet. Else, keep increasing frame timer by delta time. This code will animate sprite sheet from here, and when this triggers, we also reset frame timer back to 0 so that it can count again towards the next periodic event. So inside animation loop, we are calculating delta time, the difference between timestamp from the current and the previous animation loop. Delta time is the amount of milliseconds it takes our computer to serve one animation frame. Frame timer starts at 0 and it adds more and more delta time as animation loop runs, until it is more than frame interval. Frame interval is the breakpoint that, when reached, it triggers our periodic event. When we reach it, we handle sprite animation and we reset frame timer back to 0 so that it can count again towards the next periodically served animation frame. I know this was a lot, but this technique is very important. It will become easy to understand when you use it more often, trust me. Now the character is animating slower, just the sprite swapping, not the actual movement speed over canvas. You can really see that when I set FPS to 2 frames per second. It still slides over canvas smoothly at 60 FPS, but we are throttling how fast the next frames in sprite sheets are served. I hope this makes the difference clear. I can try other values as FPS. I have to experiment a bit here and find the right value that will make the legs move at the speed that feels natural as the player moves over the grass terrain. 50 is still some sliding. 60. We are actually not accounting for leftover values of delta time every time we trigger our periodic event, so even though I set FPS to 60, the real FPS would be less than that. For the purposes of a project like this, it's perfectly fine. We have a value, we can increase and decrease to control sprite animation. It serves its purpose well. I can simplify this line of code and use ternary operator to write all of this on a single line. Let me show you, it's easy. Ternary operator is the only JavaScript operator with 3 operands. We will use it as a simple one-line if-else statement. We have condition to evaluate, so we check if frame x is less than max frame. If it is, question mark, increase frame x by 1. Else, reset frame x back to 0. Now, this single line of code does the same thing as this multi-line else if statement. You can use either syntax, I just wanted to show you. Let's create some objects and spread them randomly around the game world. I create a class I call object. As usual, it will expect a reference to the main game object from line 111 as an argument, so that we have access to all important properties from there. And we convert that reference to a class property, same as we did before. Draw method will expect context as an argument. Inside we call built-in draw image method. I want to show you how to extend classes and take advantage of inheritance, which is one of the main principles of object-oriented programming, how we can use it to reduce code repetition. I create a class called bush that extends object class from line 102. It will have a constructor as well. I create another class I call plant and one more I call grass. We have the main object class and we have 3 classes, bush, plant and grass, that extend that object class. Object is so-called parent class, also called a superclass. Bush, plant and grass are child classes, also called subclasses. If I use a property or a method inside one of these child classes and that property is not defined on that subclass, JavaScript will go look for it automatically on its parent class, on object, and that way I can only define this draw method once, and all child classes that extend this parent class will automatically have access to it. They inherit that method. We can do something similar with properties inside constructor using super keyword. I will show you in a minute. Object class will hold all properties and methods shared between all child classes. Bush, plant and grass will contain properties that are specific only for that particular subclass. For example, each subclass will have a different image, but all will pass that different image to the same draw method from line 107. Let's do it. Before I can use this keyword inside child class constructor, I need to trigger constructor on its parent class. When I say super like this here, it means I want to run a constructor of this class's parent. Parent class is also called a superclass. On line 103 I can see that object class constructor expects game as an argument, so I pass this reference along. At the same time I convert it to a class property on bush class as well, like this. Inside the shared draw image method I pass it this.image, this.x and this.y. I can also give it this.width and this.height if I want to scale the images. As you can see, none of these are present on this class. I want each subclass to have a different image and we need to know size of that image to calculate its randomized position. So I will have to put all these properties on each subclass separately. Let's start with bush. This.image will be document.getElementById, and here in index.html I need to create that image element. As usual, you can download the images in the project resources section below. I put it here, ID will be bush, another one with an ID of plant, like this, and the last one will be grass. In style CSS I use their IDs to hide these images. We want to draw them on canvas, not as actual image elements on the web page. So the ID is bush. I duplicate this code. ID here will be plant and here grass. I'm trying to keep the naming simple and clean. I don't really want to scale the images, but if we want to leave the option for scaling open, maybe it's better if I define image width and image height properties separately, even though at this point they will have the same value. I already sized the images to be the same size as we will draw them on canvas, which is a good practice. Bush image is 216 times 100 pixels. I could also define these properties on one line like this. It's up to you. Horizontal exposition will be a random value between 0 and the width of the game area minus the width of the image itself. This will probably need some adjustments. Let's see. Vertical Y position will not start from 0. It will start from top margin, and from there a random value between 0 and game area height minus the height of the image minus top margin, I think. When we start drawing them, we will see if I need to make any adjustments here. Let's test it. On the main game class, I create a property called number of plants. Let's create 10 randomly positioned plant objects. I create initialize method that will run only once on the first page load, and it will randomly position the objects. Inside, I create a for loop. It will run 10 times. Every time it runs, we create one plant. I create an empty array here that will hold all the plant objects, and every time the for loop runs, I take this .plants array and I push new bush object inside. On line 111, I can see that bush class constructor expects game as an argument, so I pass it this keyword because we are inside that game class here. After I create an instance of game class on line 160, I can call this init method. It will run and it will fill plants array with 10 randomized instances of bush class. If I want to display them on canvas, I need to call their draw method. I will do it from inside render. I take plants, and for each plant object inside the array, I call their associated draw method from line 106. That method expects context, so I pass it along this context reference. Nice, I'm drawing 10 randomly positioned bushes. I go up here, I will copy all these properties that are specific for bush class, and I copy them here inside plant class. I check the image, width is 212 pixels and height is 118. I copy it again, and grass width will be 103 and height will be 183 pixels. Nice, we defined a parent object class where we can place all shared properties and methods, and 3 subclasses called bush, plant and grass that extend the parent class. To quickly check if these classes work, I can just swap the class name here on line 168. Grass is working, plant is working. How do we randomize them and control which portion of these 10 randomly generated plants will be bush, grass or plant objects? One simple way to do it is to create a variable here I call, for example, randomize. It will be equal to math.random. We know that math.random code like this on its own will return a random value between 0 and 1. Let's say I want roughly 30% of these objects to be instances of plant class. I say if randomize is less than 0.3, else if randomize is less than 0.6, so when math.random rolls between 0.3 and 0.6, we create an instance of bush class. Else, meaning when math.random rolls between 0.6 and 1, we create grass. It doesn't work because this has to be inside the for loop, because we want to roll each time we create a new object, not just roll once for all 10 objects. Perfect, we are extending a class to create 3 different randomly positioned game objects. Nice work! As you can see, the way these objects are being positioned and the way the game is layering doesn't really make much visual sense. Owlbear is drawn first on line 162, and then all plants are drawn after, so plants will always be on top of Owlbear. If I swap this around, then plants are always behind the Owlbear. Since we are drawing everything on the same canvas element, whatever gets drawn first is behind, and whatever was drawn after is on top, in front of it. I want to draw objects in a specific order based on their vertical positions. More specifically, based on the vertical position of their bottom edge, because each object has a different height, to make sure they are aligned in a way that makes logical and visual sense, and so that our character can walk around them and be in front and behind the objects when appropriate. We are trying to simulate a virtual world where plants grow from the ground and where this owlbear is walking on solid ground at all times, even when it walks up and down, so the layering has to match that visually. It's actually very easy to achieve this. I just need to make sure that all these objects, so owlbear, and all plant objects are in the same array so that I can sort them based on their vertical position. I create another array called this.gameObjects. Every time render method runs, I put owlbear object inside and I spread all objects from this.plants into this array. Spread operator used like this allows us to expand one array into another one. In this case, it doesn't make much sense to do this every time render method ticks for every animation frame, since we have just owlbear and 10 static plants. We could have done this inside init method. It would just make sense to do this periodically to construct this array over and over if we have more objects that are being added and removed over and over, for example enemies or power-ups that come and go. So now we have owlbear and all 10 plants on the same level inside the same array. I can take this array and for each object in GameObjects array I call their draw method. When we do this and we combine different object types into a single array, we need to make sure all these objects actually have draw methods defined in their classes. Be careful about brackets here. I can delete this code. I will have to call update method and pass it delta time, otherwise owlbear will not move or animate. When I call update like this, we draw and update owlbear, and when I try to draw and update the first out of 10 plants, it gets drawn, but there is no update method to run, so we get an error. I need to add update method on object class for this code to run. We are not really updating the objects, but here we can have some animations. For example, bushes and grass can move when the player touches them. That code would be handled inside this update method. I will leave it blank for now. Now we have the same thing we had before, but all elements that need to be layered dynamically are being drawn and updated from inside GameObjects array. Owlbear is first in the array, that's why it gets drawn before plants. Plants are drawn on top of it. If I swap them around, plants are behind and owlbear is drawn last, so on top, because that's the order in which for each method cycles through GameObjects array to call their draw methods. So we want to sort owlbear and all 10 plants in this array based on their vertical y coordinate, but not based on their top, but on their bottom boundary, because we have objects with different heights. We can do this using built-in array sort method. The sort method sorts the elements of an array in place and returns the reference to the same array, now sorted. It takes an optional argument we call a compare function, where we can define logic that describes the sort order. If we don't define sort condition, by default all array elements are just converted to strings and sorted based on characters' Unicode values. A is the first element for comparison, B represents the second element for comparison. Sort method will automatically compare every element in the array against every other element to sort them based on our requirements. We wanted the sort condition to compare the bottom boundary of each element drawn on canvas, so its vertical y position plus its height, like this. I'm saying sort all elements in ascending order based on their vertical position plus their height. Once the array gets sorted, we draw plants and owlbear in that order on canvas, and now everything makes visual sense. We can walk around obstacles and we can see that the player character and plants are now always correctly drawn in front or behind. These plants are soft obstacles. If you want to know how to handle solid obstacles, we will cover that later in the class. Check out the extended version for a bonus for directional character. You can expand this game in many different ways. Create mushrooms that grow in playable area to make the owlbear grow as it eats them, or you can make it avoid dangerous enemies or walk around spiky obstacles. I suggest you create a copy of this codebase and you can use it as a base for different gameplay experiments. In the next class, I will give you more free animated characters and environmental art assets that match this art style, so we will be able to mix and match things and create different games with the techniques we are learning. I'll see you there.